So you are going to be required to be able to graph any logarithm with any number here. In this case, we're doing a 4. So what do we know? Logarithms are the inverses of exponentials. So for this very first one, I'm going to show you how we can use what we know about exponentials to graph logarithms. But then after this first one, I'm going to expect that when you see this, you'll be able to draw this immediately. You will know the following 2 points and the following shape, along with the asymptote. The 2 points you're going to know is that every log graph goes through 1, 0. And if logs solve for exponents, what number is easy to put in for x that you know the exponent for? Well, if x was 4, and you were solving for the exponent, 4 to what exponent is 4? 1. So you'll always know that every log graph goes through 1, 0, and the base, 1. But for now, logs are the inverses of exponentials. So if I have log base 4 of x, it's the inverse of y equals 4 to the x, and the graph of y equals 4 to the x, well, every exponential graph goes through 0, 1, and 1, its base, and has an asymptote at y equals 0. And its shape looks like this. In chapter 3, we did inverses. Graphically, what happens when you do an inverse? All the x's and y's get flipped. So notice that if we have 0, 1 on 4 to the x, does it make sense that we have 1, 0 on the log graph? We have 1, 4 on 4 to the x. We have 4, 1 on the corresponding log graph. The asymptote of y equals 0, x's and y's switch here too, now is x equals 0. You just switch the y to an x. And so we are going to do a whole bunch of graphs with a whole bunch of different logs and do all the transformations, don't cheer so loud, with our log graphs. Okay, but first of all, do we have any intercepts? Well, there's only an x-intercept, no y-intercept. The equation of the asymptote is x equals 0. If you wanted to do the domain, x is bigger than 0, your range is everything. So we're going to do all of our transformations with log graphs as well, but I'm going to add, you can add this at the bottom of page 378. There is space there. We're going to graph the natural log of x. So there's 2 special logs. There's the common log, which I'm circling in green here, where if you don't write anything, you imagine a 10 there. And that's one of the log buttons on every single scientific calculator. Then there is another special logarithm called the natural log. And I think the French did it first because they got the L first, or like logarithm naturel or something that way. The L is first in the end. Stands for natural log. And again, no base is written. There's a hidden E. Do you remember E? That number that was like 2.71828 ... That goes on forever. Just like pi. So if we were going to graph the natural log of x, well, again, any log graph, we need to know that we have an asymptote here at x equals 0. Every single log graph will go through the point 1, 0. And this one will go through the point E, 1. So when graphing log graphs, they all look the same. The only thing that's going to change is depending on what base that you're using. All right, questions for practice for graphing are 10 and 11.